Imagine a Wall Street banker evaluating a tech company the exact same way they would value a heavy industrial operation, like a deep-sea oil rig or a global shipping fleet.
Right, which sounds totally counterintuitive.
It really does. But today, we actually have the data proving that AI has crossed this major threshold.
Yeah.
It is no longer just, a software update. It's heavy industry.
Yeah, it forces a complete mental pivot.
Yeah.
Because we're so used to thinking of technology as something intangible, right?
Mm-hmm.
Like just code living in the cloud.
Mm-hmm.
But the intelligence infrastructure being deployed right now is literally as physical and, well, capital intensive as a steel mill.
Exactly. And there is this incredibly vivid image in today's sources that captures this shift perfectly. So for you listening, we're pulling from the Koda Daily Intelligence Brief and its visual digest for April 10th, 2026.
That's a fascinating brief today.
It really is. And the main visual for the lead story is this towering, monolithic neural core. It looks almost like a stylized flame rendered in polished obsidian and chrome.
Yeah, rising up from that platform etched with the Meta Infinity logo.
Right. And it has these pulsing veins of electric blue and purple energy and concentric rings of holographic data just orbiting it. I mean, it looks like a prop from a sci-fi blockbuster.
Oh, absolutely.
But the thing is, this isn't science fiction. This is a real visual representation of a product that just completely rewired how the market values the world's sixth largest company.
Yeah, the aesthetics are striking, but what that image represents structurally is what we really need to focus on today.
For sure. And that is exactly our mission for this deep dive. We want to understand how we've crossed this inflection point.
Because, we've spent the last few weeks in the tech world just endlessly talking about trillion parameter model races and geopolitical chaos. But today's data reveals a totally new paradigm.
It really does.
We're seeing radical accessibility colliding head-on with physical embodiment.
Okay, let's unpack this. We need to start with the business transformation angle because that glowing Spark visual we just talked about, that is actually the branding for Muse Spark, which is the very first model released by the newly formed Meta Superintelligence Labs. And man, the financial shockwave from this single product launch is unprecedented.
It's massive.
JPMorgan immediately put out an overweight rating on Meta and slapped an $825 price target on the stock. That implies a near 35% upside.
Yeah, and what's really fascinating here is the underlying rationale for JPMorgan's upgrade. I mean, they are predicting a bump in user engagement because of some, fun new chatbot feature.
No, it's not about ad clicks.
Exactly. This upgrade is fundamentally about validating infrastructure. Over the past couple of years, companies like Meta have just poured billions of dollars into gigawatt-scale compute clusters.
Well, let's pause on that phrase for a second. Gigawatt-scale compute clusters.
Yeah.
Because it's so easy to just gloss over that jargon. What does that actually look like in the physical world?
Well, we're talking about data centers so sprawling they require their own dedicated power plants. Yeah, facilities consuming the same amount of electricity as a medium-sized city. And they're filled with hundreds of thousands of highly specialized chips, all running so hot that they require literal rivers of water or, specialized liquid cooling just to keep from melting.
That is insane. And the capital expenditure required to build just one of these clusters is staggering.
Absolutely staggering.
Which, brings up a natural skepticism. From an outsider's perspective, couldn't this just be a massive sunk cost fallacy? Like, tech giants spent all this money on specialized chips, so Wall Street is just desperate to see anything really come out of the oven to justify the expense.
That is the exact tension that has been hovering over the market. Investors have been holding their breath, just wondering if that immense physical and financial investment would actually yield proportionate cognitive power.
Right.
And Muse Spark is basically the sigh of relief. It proves the architecture works. JPMorgan is signaling that those billions of dollars weren't just burned on some speculative research project.
They actually got something for it.
Exactly. They were successfully converted into a tangible, producing asset.
So it really is like an energy company finally pulling oil out of the ground after spending 5 years building the offshore rig.
Precisely. They are valuing Meta's proprietary superintelligence as foundational infrastructure. It's this walled garden of immense cognitive output.
But wait, if Wall Street is aggressively rewarding these proprietary, highly guarded superintelligence models with these massive valuations, what happens to that business equation when other major players decide to take that exact same foundational intelligence and just hand it out to the public for free?
Well, that's the multi-billion-dollar question, isn't it?
Right, because looking at the rest of the brief, There is a fierce counter-movement happening simultaneously.
Yeah, we're seeing a massive push toward open source accessibility that directly challenges that walled garden approach. The Google Gemma 4 drop in today's digest is the prime example of this.
Oh man, let's look at the details on Gemma 4. So Google just released 4 distinct model variants, and they put them under the Apache 2.0 license.
Which is a huge deal.
Right. Now, for you listening, if you aren't a software developer, what does that specific license actually mean in practice?
It basically means Google is giving developers incredible freedom. An Apache 2.0 license essentially says, hey, you can use this software, modify it, distribute it, and crucially, you can use it for commercial purposes without paying Google royalties.
Wow, so no licensing fees to build a business on it.
Exactly. There are some basic protections involving patents and liability, but practically speaking, Google is just handing over highly capable enterprise-grade AI architecture to the public.
And according to the Hugging Face Spring 2026 report that's included in our data, developers are not just taking these models and using them as is. The report tracks this compounding velocity of community model merges.
Yeah, and this is where the open source community begins to outpace centralized corporations.
How so?
Well, a centralized lab has a linear development cycle, right? But the open source community operates like an evolutionary pressure cooker.
Oh, I like that phrasing.
Yeah, developers take a base model like Gemma 4, they blend its weights with another model that was trained specifically on logical reasoning, and they create a highly specialized variant in a matter of days.
That is wild. And the extremes of scale happening in this open source arena are what really caught my eye today. On one side of the spectrum, you have China's Zhipu AI. They just shipped a model called GLM 5.1.
Right, the massive one.
Yeah. The brief states it is a 744 billion parameter mixture of experts model, and it was released under an MIT license. First of all, the MIT license is even more permissive than Apache. It basically removes almost all restrictions.
It's as open as it gets.
But let's break down that mixture of experts part. With 744 billion parameters, how does a computer even process a request without just instantly crashing?
That is the genius of the mixture of experts, or MOE architecture. Think of a standard AI model, like a general practitioner doctor who is trying to memorize every single medical textbook in existence.
Sounds exhausting.
It is. It requires immense effort to recall everything all at once. And MOE model operates more like a massive modern hospital.
Oh, so routing the patient to the right floor.
Exactly. These 744 billion parameters are broken down into specialized expert neural pathways. So if you ask the model to solve a complex calculus problem, it doesn't wake up the creative writing department or, the language translation department.
Right, it just uses the math guys.
Exactly. A routing mechanism looks at your prompt and only activates the specific pathways, maybe just 40 billion parameters that are trained for mathematics. It provides immense scale and nuance, but only uses a fraction of the computing power at any given moment.
That is brilliant. It's efficiency at an incredible scale. But then, on the total opposite end of the spectrum, the digest highlights a release from Prism ML called Bonsai 8B.
Yes, the one-bit model.
Yeah, this is described as a one-bit quantized language model designed for highly constrained hardware. Now, going from 744 billion parameters to 1 bit sounds like we're speaking a completely different language. How does quantization actually work?
To understand quantization, imagine taking a massive, highly detailed, high-resolution photograph. The file size is huge because every single pixel contains complex data about color, light, shadow, all of that.
Right, like a giant raw image file.
Exactly. If you need to send that photo over a really slow internet connection, it's going to take forever. So quantization is essentially the process of compressing that data.
Okay, so it's like compressing the high-res photo down to a simple black and white sketch.
That is a perfect analogy. You lose the subtle gradients of color, but the structural integrity of the image, the outline of the face, the shape of the building, remains completely recognizable.
Got it.
In computer science, AI models normally use 16-bit floating point numbers to represent the strength of the connections between neurons, and that takes a lot of memory. A 1-bit quantized model drastically simplifies those connections. It essentially rounds them down to basic binary states, like a positive one or a negative one.
Okay, so it's trading just a tiny bit of nuance for an extreme reduction in file size.
Yes, and that reduction is profound because it solves the memory bandwidth bottleneck. A 1-bit model doesn't need a server farm. It doesn't even need a high-end laptop.
Wait, really? Where does it run?
It can run locally on an older smartphone, a smart home appliance, or an edge device out in a warehouse.
Which fundamentally changes the latency, right? Because if the model lives directly on my phone, it doesn't have to beam my voice up to a cloud server, wait for processing, and then beam the answer back down. It just reacts.
Exactly. It creates a seamless, instantaneous interaction. This is the ultimate democratization of inference. It takes the intelligence that used to require a gigawatt data center and shrinks it down so it can live invisibly in our physical environment.
And the product landscape section of today's digest proves this isn't just theoretical computer science. Look at Nova Voice. It just hit #1 on Product Hunt.
Yeah, that app is wild.
Because of these efficient localized models, Nova Voice creates a single zero-latency voice layer for device control. You don't have to open a specific smart home app or dictate into a specific text field anymore. The device just understands your intent locally and executes it.
We also see this disrupting traditional enterprise software with tools like Lessee AI. Historically, lead generation and sales meant a human sitting at a screen, clicking through rigid database filters, just trying to guess the right parameters.
Oh, the worst part of sales.
Right. Lessee AI changes the mechanism entirely. You just use natural language to describe the type of client you were looking for, and the AI agent independently crawls the web, surfaces the matches, and drafts the outreach. The intelligence is doing the heavy lifting of navigating the software.
And even OrbitMeet is pushing boundaries by acting as a real-time meeting co-pilot. Like, it's not just a transcription service that emails you a summary an hour after the call ends.
No, it's way faster.
It's processing the conversation locally, surfacing action items on your screen while you are still speaking. It allows you to confirm deliverables before you even hang up. Oh, and Google Colab's Learn Mode is doing something similar, turning Gemini into this persistent personal coding tutor.
Yeah, and we should note, even Meta, despite banking on their proprietary Muse Spark, they are leaning into this open ecosystem too.
Oh, with the environmental tracking?
Yeah. They partnered with the World Resources Institute to release Canopy Height Maps V2, openly distributing planetary-scale environmental tracking data to monitor global deforestation.
Which is great. But okay, here's where it gets really interesting, though, and I want to push back on this entire trajectory.
Okay, go for it.
If a one-net model can run effectively on a toaster, and a 744 billion parameter hospital of experts is available to download for free, doesn't intelligence just become a cheap commodity, like electricity or tap water? Because if every developer has access to it and it costs almost nothing to deploy on edge hardware, where is the actual economic value?
Well, you're touching on the exact paradox the market is wrestling with right now. Software intelligence by itself is rapidly becoming a commoditized utility.
Right.
But that commoditization is exactly what unlocks the most disruptive element in today's data. The software brain might be essentially free, but the physical world is experiencing the exact opposite trend.
Okay, and to understand that, we need to look at the macroeconomic and geopolitical facts from today's digest. And, for everyone listening, I want to be super clear here. I am just conveying the data straight from the source material to establish the state of the global supply chain.
Right, just looking at the friction.
Exactly. We aren't endorsing any political viewpoints, but looking purely at the statistics, the situation is incredibly tense. The brief classifies overall market sentiment as extreme fear.
Which is a lot.
Oil is sitting at nearly $97 a barrel. Cyclone Vaianu is disrupting Pacific lanes, which is threatening long-term fuel price hikes. And shipping traffic through the Strait of Hormuz is experiencing massive stalls right now amid President Trump's accusations against Iran. Plus, we're seeing devastating airstrikes in Lebanon that killed over 250 people.
Yeah, it's a very unstable global picture. And if we connect this to the bigger picture, the data paints a very clear reality.
Which is?
Relying on traditional global logistics, moving physical materials, and employing human labor to handle those materials has become exceptionally fragile and expensive right now. The physical world is just full of friction.
So while the digital brain is getting cheaper, the physical hands required to do the work are getting much, much more expensive.
Exactly. Which is why the hardware announcement buried in the back of today's digest is arguably the most important piece of information we have.
Clone Robotics.
Yes.
They have officially announced the pricing for their synthetic human android, and the number they landed on is exactly $20,000.
And that specific price point completely rewrites the equation for physical labor.
Let's break down what this machine actually is, because when you say android, it kind of conjures up images of clunky metal boxes on wheels.
Like old sci-fi movies.
Exactly. But the sources detail that this synthetic human mimics actual human biomechanics. It doesn't use traditional electric motors. It utilizes synthetic skeletal, muscular, vascular, and nervous structures to achieve a 99% task accuracy rate.
It's incredibly advanced, biology-inspired engineering.
And they are selling it for the price of a heavily used Honda Civic.
Yeah. And this is where the commoditization of the software brain becomes crucial. Think about it. If a robotics company had to spend hundreds of millions of dollars developing a proprietary superintelligence just to make their robot walk and understand basic commands.
They'd have to charge a fortune.
Right, that robot would cost $1 million per unit.
Yeah.
But because they can take a radically accessible open-source reasoning engine, perhaps even a localized one-bit quantized model, and use it as the robot's central nervous system essentially for free, the only cost they have to pass on to the consumer is the physical bill of materials.
The actual parts.
Exactly.
Yeah.
The plastic, the synthetic actuators, the battery.
So they basically downloaded the brain for free, so they only have to charge you for the body.
And at $20,000, a business isn't just buying a piece of machinery. They're purchasing a fully functional, physically embodied worker capable of mitigating that immense supply chain friction we just talked about.
The thematic contrast of all this happening at the exact same moment is just wild to me.
How so?
Well, today's digest also notes the Artemis II crew just splashed down. They completed a historic crewed lunar flyby. I mean, it is humanity at its most exploratory, reaching outward into the solar system.
It's a huge achievement.
Right. And yet, simultaneously, down here on Earth, we are synthesizing human biology to pack boxes and load trucks because our own logistics networks are too fragile. AI is no longer just a voice coming out of a smart speaker on your counter. It is physically walking the factory floor.
It really is a profound duality.
Yeah.
We are pushing the absolute limits of human capability in space while simultaneously engineering our own synthetic replacements to handle the friction of gravity and commerce down here.
So what does this all mean for you listening? The landscape has shifted dramatically. We started today by looking at Wall Street officially treating AI as heavy industrial infrastructure.
Right, rewarding Meta's Muse Spark.
Exactly. Because it proves those gigawatt-scale hardware investments actually produce tangible cognitive output. Then we saw how that same level of intelligence is becoming radically accessible, almost like tap water through open-source drops like Google's Gemma 4 and the extreme efficiency of one-bit quantized models.
Shrinking the brain down.
Right. And finally, we saw the inevitable result of that free intelligence colliding with the physical world. A $20,000 synthetic worker from Clone Robotics stepping in to solve the escalating costs of global supply chains.
It requires a fundamental shift in how we project the future of business. And I'll leave you with this final thought to consider.
Hear it.
If a synthetic physical worker costs $20,000 today, which, keep in mind, is a one-time capital expenditure, and the open-source software powering its cognitive abilities is essentially free and shrinking down to run on minimal localized power, how long is it until companies simply stop utilizing the concept of payroll entirely? How long until a corporate labor budget is completely replaced by a spreadsheet calculating nothing more than the local cost of electricity and routine hardware maintenance?
Wow. That is a staggering thought to end on. It completely rewrites the basic math of how a global economy operates. Well, thank you for joining us on this deep dive into the sources today. Keep questioning, keep exploring, and we will see you next time.